What if the dream of finding alien life is a cosmic mirage? We often picture new Earths, but what if the universe is actually a vast graveyard of planets that almost made it? Join us as we explore the unsettling fate of exoplanets that had all the ingredients for life, only to succumb to unseen forces. This journey into exoplanet graveyards might just change your perspective on humanity's place in the cosmos. Forever, for decades, the search for life was guided by a simple, elegant idea: the habitable zone. You've probably heard it called the Goldilocks zone. It's that orbital sweet spot around a star, not too close, not too far, where the temperature is just right for liquid water to exist on a planet's surface. Not so hot that the oceans boil away, not so cold that they freeze solid. Since liquid water is the one non-negotiable for life as we know it, this became our treasure beast. The Kepler Space Telescope, Webb's predecessor, was a revolution. It found thousands of planets, revealing that our galaxy is teeming with worlds. A thrilling number of them were Earth-sized, and in that coveted Goldilocks zone, the stage seemed set. Statistically, some of them had to be winners. We imagined these worlds in vivid detail. Planets with continents and oceans, maybe shrouded in clouds, just waiting to be found. The dream was that jwst, with its unparalleled power to see in the infrared, would finally confirm this vision. Infrared light is perfect for this. It allows us to dissect the light passing through a planet's atmosphere, looking for the chemical fingerprints of life: water, methane, oxygen. It's like performing a chemical analysis from light years away. If the Goldilocks zone was the map, jwst was the ultimate detective, equipped to follow the clues. But the story that began to unfold was not the one we expected. The detective was finding crime scenes, planets residing squarely in the habitable zone, which should have been temperate and welcoming, were turning up hostile and barren. A prime example is the TRAPPIST-1 system, about 41 light-years away. It's a tantalizing system with 7 rocky Earth-sized planets orbiting a small, cool red dwarf star. At least 3 of these worlds orbit within the star's habitable zone. It was our best-case scenario, so Webb turned its golden eye to the innermost planets first. It looked at TRAPPIST-1e. The verdict was stark. With no atmosphere to trap and circulate heat, the planet's dayside is a frigid -63 degrees Celsius, or -82 Fahrenheit. It wasn't a scorched rock. It was essentially a bare, frozen rock. Hopes then turned to the next planet out, TRAPPIST-1c. This one is closer in size to Earth. Scientists wondered if it might be a Venus 2.0, with a thick CO2 atmosphere. But Webb's observations, confirmed through 2025, told a different story. The planet is a bare rock with no detectable atmosphere. This wasn't just a fluke. A pattern was forming. Webb looked at other planets, and the story repeated. We expected gardens, but we were finding deserts. The simple idea of the Goldilocks zone was proving to be just that: simple. It's a necessary condition for a habitable world, but it's nowhere near sufficient. We were discovering that a planet can be in the perfect location and still die. We were learning that there are 1,000 ways for a world to fail, and only a very narrow path to success. The galaxy is full of Earth-sized planets in Earth-like orbits, yet they look nothing like Earth. We had to ask a new question. We were no longer just searching for habitable worlds. We were now investigating the murders of dead ones. To understand why so many of these promising worlds are ending up as cosmic graveyards, we have to look at the stars they orbit. And that leads us to the biggest culprit in the galaxy, the red dwarf star. These stars are, by a huge margin, the most common type in the Milky Way, making up about 75% of the total. They are small, cool, and incredibly long-lived. A red dwarf can simmer away for trillions of years. For decades, this made them seem like ideal places to search for life. A long-lived star gives life a massive window of time to emerge and evolve. The TRAPPIST-1 system seemed to be the poster child for this promise. But that promise has turned into a deception. JWST's observations are revealing that these red dwarf systems are not gentle cradles for life. They are, often, violent, destructive environments. The first problem is proximity. Because a red dwarf is so dim, its habitable zone is huddled incredibly close. All 7 planets in the TRAPPIST-1 system orbit far closer to their star than Mercury does to our Sun. This leads to a huge problem: tidal locking. Just like our moon always shows us the same face, these planets become locked to their star. One side is trapped in perpetual daylight, while the other is frozen in endless night. For a planet to be habitable like this, it would need a very thick atmosphere to circulate heat from the day side to the night side. Without it, the day side bakes, while on the night side, the atmosphere itself would freeze and collapse. You'd have one side of the planet sterilized by heat, and the other by cold. This is where JWST's findings are so crucial. The observations of TRAPPIST-1b and 1c show they lack the thick atmospheres needed to survive. But why? Why are they losing their atmospheres? The answer is that red dwarfs are cosmic bullies, especially in their youth. For their first billion years or so, they are ferociously active, unleashing powerful stellar flares and blasts of high-energy radiation. A planet huddled close for warmth is hit with a relentless cosmic blowtorch. This intense radiation is devastating for a young atmosphere. It's a process called atmospheric stripping. High-energy photons heat the upper atmosphere, giving gas molecules enough energy to escape the planet's gravity and bleed out into space. JWST is seeing this process in action. Take the exoplanet WASP-121b, a so-called ultra-hot Jupiter. In early 2026, JWST confirmed it isn't just leaking atmosphere. It's being torn apart, trailing 2 colossal tails of escaping helium gas that stretch across a huge portion of its orbit. It's a real-time visualization of a planet being devoured by its star. Another fascinating case is WASP-107b. This planet is nicknamed a cotton candy world because it's the size of Jupiter with only a fraction of its mass. Its low density let JWST peer deep into its atmosphere and find clouds of silicate, essentially sand. On WASP-107b, it literally rains sand. But the picture became even more dramatic in late 2025. JWST detected a colossal halo of helium gas escaping the planet, stretching out more than 10 times the planet's radius, with tails streaming ahead and behind it. We are watching this fluffy world get blown away into space. This brings us back to the most tantalizing planet in the TRAPPIST system, TRAPPIST-1e. It sits right in the middle of the habitable zone. On paper, it's the best candidate we know of for an Earth-like world. So, what has Webb found? The science is ongoing, but the initial results show that it does not have a thick, Venus-like CO2 atmosphere. That's good news, but the results are also consistent with a bare rock, a world with no atmosphere at all. There are some tantalizing but uncertain hints of a thinner atmosphere, maybe rich in nitrogen like Earth's. The problem is, the star itself is so active that its flares can create signals that mimic or mask an atmosphere. Scientists are now developing new techniques to subtract this stellar noise from the data. It's a painstaking process, and more observations are needed. The jury is still out on TRAPPIST-1e. It could be an airless rock, another victim of its violent star, or it could be clinging to a thin, precious atmosphere. But the lesson from the red dwarf deception is clear. The habitable zone around these stars is also a kill zone. The proximity required for warmth is a sentence of constant bombardment. These systems are not the gentle havens we hoped for. They are arenas where planets seem to be fighting a losing battle against their own suns. While a violent star is an efficient planet killer, it's far from the only one. jwst's growing catalog of exoplanets is like a planetary morgue. By performing these long-distance autopsies, we're uncovering a whole range of fatal conditions. A planet can survive its star's youth only to die a slow death from the inside out. One of the most critical life support systems for a planet like Earth is its magnetic field. Our planet's spinning, molten iron core generates a powerful magnetic shield that deflects the solar wind, protecting our atmosphere from being slowly stripped away. Without it, Earth would look a lot like Mars. Mars is a tragic case study in death by geological silence. Billions of years ago, it was a warmer, wetter world. It had rivers, lakes, maybe an ocean under a thick atmosphere. But Mars is only about half the size of Earth. It cooled down much faster. As its core solidified, its magnetic dynamo died. The shield went down. With no protection, the sun's radiation stripped Mars's atmosphere away over millions of years. The water was lost to space, and the planet transformed into the cold desert we see today. Size, it turns out, really matters. A planet needs to be large enough to hold its internal heat and keep that protective shield online. Gravity itself can also be a killer. We see this in hot Jupiters, gas giants that now orbit their stars in blisteringly fast orbits. For Kepler 1658b, a planet more massive than Jupiter, the immense gravitational pull of its star is causing its orbit to shrink. It's being pulled into a slow, inexorable death spiral. For the first time, astronomers have seen this orbital decay happening. By tracking the planet's transits, they found its orbital period is decreasing. It's spiraling inward, destined to one day be consumed by its star. Even the death of a star doesn't mean the end of the story. JWST has observed planets orbiting white dwarfs, the dense cores left behind after a star like our Sun dies. These systems are true cosmic graveyards. When astronomers look at the atmospheres of some white dwarfs, they see they're polluted with heavy elements like magnesium and iron. These elements should have sunk into the core. Their presence is direct evidence that the dead star is actively consuming the remains of its own planetary system. Asteroids, comets, and even entire planets, gravitationally shredded and now raining down onto the star's surface. We're seeing the literal guts of destroyed worlds being cannibalized by their stellar corpse. The universe doesn't just kill worlds, it desecrates the bodies. A planet's fate isn't just tied to its star, it also depends on the neighborhood. The galaxy is a dynamic and often violent environment. One surprising fact is that our Sun is somewhat unusual for being alone. Many stars, about 44% of stars like our Sun, exist in binary or multiple star systems. Living in a multi-star system can be like living in a gravitational blender. A distant companion star can, slowly but surely, perturb a planet's orbit, stretching its circular path into a long, oval one. This can cause catastrophic swings in temperature, or worse, destabilize the orbit entirely, either flinging the planet out into interstellar space as a rogue planet or sending it plunging into its star. A stable, nearly circular orbit like Earth's might be a rare luxury. The galaxy itself also has its own version of a habitable zone. Too close to the galactic center, and the environment is extremely dangerous. The density of stars is higher, increasing the chance of disruptions. More importantly, the rate of cataclysmic events, like supernovae, is much higher. A nearby supernova would bombard any planet with lethal radiation, sterilizing it. Life seems to need a quiet corner of the galaxy. Our solar system resides in a relatively peaceful suburb of the Milky Way, far from the dangers of the core. But even here, there are no guarantees. The universe is a cosmic demolition derby. We see the evidence in those polluted white dwarfs, each one a tombstone marking the spot where a planetary system was violently disassembled. The picture that emerges is one of profound fragility. To be habitable, a planet needs to be in the right orbit, around the right kind of star, with the right internal properties, in the right kind of star system, in the right part of the galaxy. It's an astonishingly long list of requirements. A failure at any step leads to a dead world. The cosmic graveyards jwst is uncovering are not the exception. They may very well be the rule. We're learning that the universe is incredibly skilled at destroying worlds. But this raises an even more profound question. How did our own planet survive? Before we explore the incredible series of fortunate events that led to Earth, if you're finding this journey into the cosmos as fascinating as we do, consider subscribing so you don't miss our future explorations. For every dead world jwst finds, the story of our own planet becomes more extraordinary. We aren't just looking at alien worlds, we're looking at what Earth could have been. Each barren rock is a testament to the fact that our existence is not a given. It's the result of a long, improbable chain of cosmic luck. So, how did we dodge so many bullets? It all begins with our star. The Sun is a G-type star, a yellow dwarf. It's not as common as a red dwarf, but it has a critical advantage: stability. It's larger and hotter, so its habitable zone is much farther out. That distance is a crucial buffer. We're far enough away to avoid being tidally locked, and to be largely protected from the sun's outbursts by our magnetic field. Our star's tantrums are far less violent than those of a young red dwarf. Our location in the solar system is also incredibly fortunate. Earth's nearly circular orbit provides a stable climate. We live in a calm, single-star system, without a disruptive companion tugging at our orbit. And we have a cosmic bouncer, Jupiter. Its immense gravity ejects many comets and asteroids that might otherwise head for the inner solar system and cause cataclysmic impacts. Then there is Earth itself. As we've seen, a planet needs to be big enough to power a magnetic field for billions of years. Earth was just the right size. Its core is still partially molten, generating the magnetic shield that has kept our atmosphere and oceans safe for eons. Mars failed this test. Earth passed. And we have another bodyguard, our moon. Compared to its parent planet, our moon is enormous. The leading theory is that it was formed from the debris of a colossal impact between a Mars-sized object and the young Earth. This violent birth had a profound and stabilizing consequence. The moon's gravity acts like a steadying hand. Earth's axial tilt of about 23.5 degrees gives us our seasons, and the moon's gravity prevents this tilt from wobbling wildly. Without the moon, Earth's tilt could vary so dramatically that the poles might sometimes point directly at the sun. The stable seasons that allowed life to flourish may be a direct gift from our oversized companion. But perhaps the most profound reason for Earth's success is a concept known as the Gaian bottleneck. This hypothesis suggests that life might emerge quite commonly on planets with the right initial ingredients. But the universe changes. Stars get brighter. Planetary interiors cool. A planet that is perfectly habitable at one point can easily become a runaway greenhouse like Venus, or a frozen snowball like Mars. The Gaian bottleneck theory proposes that to remain habitable, life itself must take control. It must become a planetary scale regulating force, a global thermostat. On Earth, early life fundamentally changed the planet. Photosynthetic organisms pumped the atmosphere full of oxygen. Biological processes helped draw down carbon dioxide, sequestering it in rocks and preventing a runaway greenhouse effect as the sun grew brighter. Life didn't just passively exist on Earth. It actively managed its environment, creating feedback loops that have kept the climate relatively stable for billions of years. According to this theory, the cosmic graveyards may not be planets where life never began. They may be planets where life failed. It emerged, but it couldn't evolve fast enough to seize control of the climate. On these worlds, non-living geology and chemistry remained in charge, and they were no match for the forces of cosmic change. Venus may have been a water world where life failed to stop a runaway greenhouse effect. Mars may be a world where life failed to maintain the atmosphere. This makes life not just a passenger on a habitable planet, but the pilot. It suggests that finding another Earth isn't just about finding a rocky planet in the right place. It's about discovering the pilot inside it. It's about finding a planet where life won a billion-year war against entropy and took control of its own destiny. The James Webb Space Telescope was built to find other Earths, and, in a roundabout way, it has. Not by showing us a galaxy full of twins, but by revealing a universe full of ghosts. Each dead world it discovers is a lesson. The blasted landscapes of planets around red dwarfs teach us the value of a stable star. The frozen surface of Mars teaches us the importance of a living geology. The chaotic orbits of binary systems teach us the beauty of our own quiet corner of the galaxy. The universe is not predisposed to create life. It is overwhelmingly hostile to it. Habitability is not a status. It is a constant, desperate struggle against 1,000 forces of annihilation. The story of our existence is the story of surviving an endless series of cosmic filters. The search, however, is far from over. Webb will continue to stare at TRAPPIST-1e, and it will be joined by new missions like NASA's Pandora satellite, launched in January 2026, designed specifically to untangle the light of stars from their planets. We will continue to sift through the cosmic graveyards, not just for signs of life, but for a deeper understanding of what allows a world to live or die. What we have learned is that a pale blue dot is not a common sight. It is a miracle. We are living on the knife's edge of possibility, on a world that against all odds survived. The dead worlds are a warning, but they are also a gift. They force us to see our own planet not as ordinary, but as impossibly, breathtakingly precious. If this deep dive into the cosmos sparked your curiosity, there are many more mysteries to explore. Click on the video on your screen to learn more about the strange worlds Webb is discovering. And as always, thank you for joining us on this journey.